Okay, last video. Yeah, it's not going to be very long, but I had to take a break. Okay, so let's see what's going on here. These terms do not have a common difference, so this is definitely going to be a geometric sequence. I know the formula for a geometric sequence is a sub n equals a sub 1 r to the n minus 1. Well, I know this is a sub 1. And I know this is a sub 2. So I can plug those in here and solve for r. So a sub 2 is equal to a sub 1 r to the 2 minus 1. So that tells me 6 is equal to 2 times r to the first, which tells me that r is 3. So now I have everything I need for here. I know my a sub 1, I have my r, excuse me. Okay, so a sub n is equal to a sub 1 times the common multiplier to the n minus 1. And there you have your sequence. All right, let's talk about some series now. Let's find some sums. So the first one goes from k equals 1 to 30 of 2k minus 3. All right, this is arithmetic. And the partial sum, s sub n, is equal to n over 2 times the first term plus the last term. All right, well, there are 30 terms, so n is 30. A sub 1 is 2 times 1 minus 3, which is negative 1. And a sub 3 is 2 times 30 minus 3, which is 57. So my sum of the first 30 terms is 30 over 2 times a sub 1 plus a sub 30, which gives me 15 times 56, which is 840. Okay, 34b. I want to go from I equals 1 to 12 of 1/3 to the I minus 1. Okay, clearly this is a geometric. Okay. And the sum of a finite geometric series, s sub n, is equal to a sub 1 times 1 minus r to the n divided by 1 minus r. Okay. Well, this is my a sub 1. A sub 1 is 1/3. My common multiplier is 2, and the number of terms is 12. So s sub 12 is equal to 1/3 times 1 minus 2 to the 12th divided by 1 minus 2. So that's 1/3 of 1 minus 4096 divided by negative 1. That's 1/3 times 4095, negative over negative 1. And so that gives me uh-oh, I've got too many papers here. That ends up giving me 1365. So it's actually negative 1365 divided by negative 1, which is 1365. Okay, then our very, very last one. Okay, it is asking us for an infinite sum. K equals 1 to infinity of negative 2/5 to the k minus 1. Okay. This is geometric, and it is infinite. And the absolute value of r is the absolute value of negative 2/5, which is 2/5, which is less than 1. So I can find the infinite sum. What that means is if you're taking a number to a power, a number less than 1 to a power, every repetition gets smaller and smaller, so you can add them all up. If it gets bigger and bigger, then there is no sum. Okay. And of course, like every other thing we do, there's a formula for it. So the sum is equal to a sub 1 divided by 1 minus r. Okay. Well, a sub 1 is equal to negative 2/5 to the 0, which is 1. And our r is negative 2/5. So my sum is going to be my a sub 1 divided by 1 minus negative 2/5, which is 1 over 1 plus 2/5. So that's 1 over 5 over 5 plus 2 over 5. 1 over 7 over 5, which is 5/7. Okay, finally, the end. See you next week.